Understanding how permissions works in AWS means understanding how Identity and Access Management, IAM, operates underneath the hood. The problem with IAM is the English language. There are words that mean obvious things, and yet when you look underneath them, depending on who is using them, depending on the context, they actually can mean entirely different things. Words like user and group and role, words that feel very familiar to us and kind of mean what you think they mean, but from an IAM point of view, we want to be extremely specific. So let's step through them. We begin with the concept of user. Now, what is a user? In the case of AWS IAM, what we are talking about here is a permanent named operator. Could be human, could be machine. It doesn't matter what it is. The idea is my credentials are permanent and they stay with that named user until there is a forced rotation, whether it's a name and password, whether it's an access key, secret key combination, whatever it is. This is my authentication method for named users in the system. All right, what's a group? Now, at this point, this one should be obvious. A group is a collection of users. Groups can have many users. Users can belong to many groups. And you're saying, Blaine, I thought you said this was going to be hard. What's a role? This is where understanding AWS IAM is important. Because in AWS IAM, a role is not your permissions. A role is an authentication method. A user is an operator. Could be human, could be machine. The key is it's a permanent set of credentials. A role is an operator. It could be human, it could be machine. The key part is the credentials with a role are temporary. So, in either case, what we are looking at is the authentication method for your user, for your operator. Everything in AWS is an API. This is critical. It also means that to execute the API, we have to first of all authenticate, but then we have to authorize. The role is not permissions, it is simply the authentication. Permissions in every case happens in a separate object known as the policy document. Now, the policy document, it's a JSON document. It attaches either directly to a permanent named user or to a group of users, or it can be attached directly to a role. The policy document lists the specific API or wildcard group of APIs that I am whitelisting, that I'm allowing, against which resources. Is it for any resource in the account? Is it for a specific subset? Are there certain conditions? Do I only want to allow it if I'm in the home network? If I'm dialed into a VPN, or do I accept it from any location? Certain times of day, I might have operators that can only do functions. All of these become elements as part of the policy document. As they're attached, here's how an API call goes through a process. Let's say, for example, that an operator wants to put an object into an S3 bucket. That's an API call. So to do that, they execute the API, put object in S3, name the bucket, name the object, and they present a set of credentials, whether it's an access key, secret key, or whether it's the username and password they use to log into the console. And all of that is the API execution statement. It gets presented to the AWS API engine. The first thing the engine does, the IAM engine, is it looks at those credentials, the username, password, the access key, secret key, and validates that those are active authorization credentials, and that validates that this is Blaine the permanent operator, or perhaps it's the role of developer for project 17, or maybe it's the group of administrators, of which it might have a whole bunch of collection of users in it. In any one of the case, those credentials are then approved, and we agree that you are the operator you claim to be. Then we take the policy documents associated with that operator, the user or group of users or the role, and we evaluate all the policy documents as a single view. And we look to see if the action you're doing, in this case, put object in S3, is authorized by any of the policy documents. If it is, great. You are then allowed to execute the API. Now, a policy document might also have an explicit deny. This overrides any allow statement. If you don't have an allow, there's an implicit deny. I have to at least whitelist a function for it to happen. But with a blacklist, with an explicit deny, it doesn't matter if I have any allow statements. I can use that where I want to permanently prevent certain actions from happening. Say, for example, I never want anyone to be able to stop or terminate assets in a production environment. I can create a policy document that denies EC2 stop, EC2 terminate against resource production and attach that to all the groups, all the users, all the roles, except for the authorized system administrator, who would be the only one allowed to deprecate an instance. That way, if you had a developer who accidentally found herself in your production environment and started terminating instances, nothing would terminate, because the deny policy would deny the delete statement, would deny the terminate statement from being executed, even though we agree that she is the developer she claims to be. Authentication, authorization. It also solves one additional problem, and that is in the case of a compromised set of credentials. Let's say, for example, that on my personal account, for whatever reason, I was sloppy with my password management. Maybe I let my kid use my laptop and he downloaded a virus on it, and someone got a keylogger and got my username and password. And I'm not using multi-factor authentication. By the way, those two things never happen in my system, but pretend it does. In that case, some nefarious hacker somewhere has got my admin username and password, which has access to all the policy documents attached to that permanent user. The hacker, on discovering they've got the keys to the kingdom, then sends a nasty, threatening hostage note to the company saying, you better hand over a bunch of bitcoins or I'll start deleting assets, and actually successfully deletes a few to prove their point. The company's in a panic. What do we do now? If you are using policy documents attached to users and you're not using root level credentials, at this point, the security manager, who doesn't know which account got compromised, can execute a single API statement that removes every policy document from all the users, groups, and roles in a single action. Now, your hijacker, on not getting a bunch of bitcoins, tries to prove the point to delete more assets because they want the bitcoins. Here's how the API action gets resolved. Hijacker submits the API with Blaine's credentials, saying delete object from S3. The API is evaluated by the IAM engine. The IAM engine agrees it is Blaine. It is the right username and password. It then checks the attached policy documents, which have been deleted from the account. They are no longer attached to Blaine, which means, nope, Blaine cannot delete any documents. But thank you for trying. Oh, and by the way, in CloudTrail, we're going to write down that you tried, because every API action is recorded in CloudTrail, successful or declined. Authentication and authorization. By understanding this distinction, you can add some significant power and security to your operations in AWS.